All right, just real quick, there's one more piece in this section that I want to make sure you guys see, and that is that if you think about it, if, like we talked about yesterday, every angle has a specific ratio of the two sides, whether it's sine, cosine, or tangent, you can take that idea and go backwards and understand that every specific ratio has an angle that goes with it. Okay? So not only can you use sine, cosine, and tangent to find the lengths of missing sides of a triangle, but you can also work backwards and use sine, cosine, or tangent to figure out what the missing angle is in a triangle instead. Okay? So let's say that we wanted to figure out what angle A is in this triangle right here.
Yeah.
What two sides do we know in this triangle relative to that angle? Alyssa, pay attention. Okay, good. I know this side right here, which is opposite angle A, and I know this side right here, which is adjacent to angle A. Which of our trig identities uses opposite and adjacent? Tangent. So I can write that the tangent of angle A is equal to what? 8 over 15. Yeah, now you want me to slow down because you weren't paying attention. Okay, so that's just the exact same thing that we were doing yesterday, right?
Yep.
Okay? What's different is what we're going to tack on with it today is that, like I said, there's only one specific angle that has that as the tangent ratio. So in the same way that we can look up and find out what the tangent of an angle is, we can look up what the angle is that has that as its tangent. And so what you need to do is get out your calculators, because the table is on your calculator. And instead of going the tangent of something, since we want to do it backwards, you're going to go second tangent. And so you should get a tangent with a little -1 symbol there. Okay? And that's called the inverse tangent, or it's also sometimes called the arc tangent.
Wait, what do you put in for like?
Yeah, what do you think for it?
What did the tangent equal? 8 over 15, right? And so basically what we're doing is we're trying to solve this equation for A, and the way you do that is by taking the inverse tangent of both sides. Okay? So the inverse tangent and the tangent cancel, and that leaves you with A equals the inverse tangent of 8 over 15. So you type in 8 divided by 15, and you get that that angle has to be about 28 degrees. Okay? So A is 28 degrees. Okay? So okay, well, if that's confusing, let's find out what the other angle is, so we can get a little bit more practice. So now let's take a look and try and figure out what angle B is. So give me a sine, cosine, tangent thing that I can do that involves angle B, and this side right here, and this side right there. Mumble, 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 whisper, whisper, whisper. Yeah, I'm going to do tangent again, but now they're flipped, right? Because now, since I'm talking about angle B, this side over here is the opposite side, and this side right here is the adjacent side. So what I was trying to tell you is, just like we were doing yesterday, you would go the tangent of angle B equals what number over what number? What? 15 over 8. But I'm trying to solve that for B, right? So how do I get rid of a tangent? I do the inverse tangent. But if I'm going to do the inverse tangent of this side, then I have to do the inverse tangent of the other side also, just like if you add two things to this equation or divide or something like that. So the inverse tangent and the tangent cancel, and b equals the inverse tangent of 15 divided by 8, which is what? About 62 degrees. Okay? Which you also could have figured out, because why? Right. This other angle right here is 90 degrees. You know that these three angles have to add up to 180. So that means that angle B has to be 62 degrees. Okay? So when you're trying to find the length of a side, you go regular sine, cosine, or tangent. If you're trying to find the length or the size of an angle, then you go second or inverse sine, cosine, or tangent. Okay? Okay. Yeah, that's it. Just wanted to finish this section today.
Right.